Hello. Hello everyone and welcome to this live stream. This live stream I've done in a while in YouTube, and I think this is the first live stream that I do on my channel. And this live stream will be dedicated in writing some Emacs Lisp so that I can manage some stuff better than how it. And I accidentally cut my mic. Okay, so let me just go where I need to. All right, so just to give you a quick background, currently I have a package that I've wrote. I'm basically the only one that uses it, if I'm not the only one altogether. Because this is such a specific use case, I don't expect many people to actually use it. Because it turns out that I create languages, construct languages, often abbreviated as conlangs, and I often need to create some featural trees, like this one that we can see here, and this image is generated through some graphviz code, but I don't want to have to go through the hassle of writing all the code myself, and especially if I want to modify the tree here or there. Thing is, I can create that through some lists in Emacs Lisp that we can see here, with the list that is declared here, and we get this list sent to this function in order to create this, to generate this graphviz code that is in turn generating the image that we saw just before. So basically, in my conlanging files, these images are stored as text only and not as images. Well, I do version these images, but they don't need to be. I could remove them from my Git repository altogether and still get my image as I get it now. But managing such lists in Emacs Lisp is pretty much a hassle in itself, and but until now I didn't have any really better idea on how to manage them. But recently on the Seasoned Crafters Discord, there is Ashraz, who showed that it was possible to use org mode lists as sources for noweb and literate programming. As literate programming sources. So if we go to a scratch buffer, am I in org mode? No, I'm not in org mode. If we create a name list, so for example test list, and we begin creating our list, so hello there, general Kenobi, and we move them in different parts, and we can get a list that looks like this. And if we take this list as the source of some Emacs Lisp code, so var list equals test list, we will also output results as verbatim in order to get an idea on how it is represented inside Emacs Lisp, how our list is represented. if we just put list and we evaluate it, we see that we get actual list with the first element being a list in itself, with the string hello that is here, and then the second element of the list, which is this one, contains itself the other element, such as, well, we get Olimwood telling us that, oh come on, that this is an unordered list. We don't really care well, I don't really care in my case whether or not it is unordered. And we get the element general, which itself contains the list Kenobi, and we also get outside of general and Kenobi, we get another exclamation mark. So if we output that as src Emacs Lisp in order to make it a bit more results. Oh no, that's not rep src Emacs Lisp. Okay, much better. So if we reorganize that in order to have some indentation, we can more clearly see the various elements from our list. And file check is a bit a pain here. But yeah, and based on that, I think it is possible to write some code that will translate our list to some actual graphviz code. So I will variable, no, this is not this, treat dot. I will try to modify my current function, which is calling treat dot here, into a function that can get hello there general Kenobi as an input and generate our graphviz code. So hello Pavel, good to see you. Let's get into it. So we get all. So I will just reproduce a list from an actual file, so we have something concrete to do, something that is, how to say it, something that I might actually use later in, not in production, but you see what I mean. So so we'll just name it vowels, and let's go from the Emacs list to an org mode list. So we begin with vowel here, and we get our back and non-back feature, tense and non-tense feature, high and non-high. Also, an advantage that I see to this is that the value here is stored as a string, and this is exactly what I need. I don't need to do anything more to say to Lisp and to org mode that I want this as a string. And the advantage of this is that even if I do, like, for example, a new line, and I don't know, I write something, and some Emacs Lisp var list equals vowels results verbatim, okay, and I put list here. You can see that here we get the new line escaped in the result, and this can be used actually in graphviz code, as we can see here with the consonants, where I have new lines around. I don't know if you can see my mouse, but in the leaves we get new lines, and this can actually just be stored as a string like this here. So for me, it's really great to be able to do that, and I think it will make my life much easier than how it is currently. So let's go back to hi, and we get our vowel here. Oh, by the way, does it? Yes, it keeps it. Well, it won't be the most legible thing once I am working on that. But this list itself won't be visible, I think, by people who will view the public document, the HTML or PDF document. So that's more of a hassle for me than it would be, and I could, in any case, just replace it with brackets. Will brackets? Yeah, I think brackets will work since it is in a string, and brackets in a string for graphviz still are, well, the character of a bracket. So I think we are good to go. I will just do that, and non-high. Yep, I can see the mouse. The maximum quality seems to be 720p there, so the letters are a bit blurry. Oh, I will zoom a bit then, because it is the maximum is 720p, because I am a bit worried about my internet connection. I do not have the fiber, so yeah. I'm on my 4G connection right now, so that doesn't look great. Well, anyway, I don't know how I could make it a bit more legible. I don't know. So let's get to, so let's copy and paste everything here. So negative tens, but we got a positive high feature and negative high feature. So here we go. Here we go. All right, so we get, and we can even fold that, which is great. Negative tens, yeah, that's all right. Yep. So negative back, so we get positive tens and negative tens. In positive tens, we get positive high and negative high, and in positive high we get the U vowel, and in negative high we get the O vowel. Alright, negative tens is okay, and now positive high again, and we also have the negative high. And inside the quotes. All right, so we get our list here, and this is what we have to work with. So The way it works with the current function is that it is a recursive function that currently if we just pass to it the tree, well, this is our condition here for, well, this is our first condition. We have no previous generation, so if optional t current generation is null, that means this is the first call. These additional optional arguments are not meant to be used by the end user. So we add already this text that will make the basics, the visual basics of our image. So let's write some Emacs Viz here and define concatenating a list to graphviz, and so we get our list optional t current generation, because the current generation is basically the current node and its children's, and we treat each node individually inside the function. And previous generations of previous nodes, so current, we'll rename that to t current node and t previous node. Okay. Node string for now. So cond now t current node. Actually, I could write it in concatenating.el. Yeah, I could. Okay, so concatenating.el, which is here. Auto load. Define concatenating tree to graphviz. It shouldn't be called dot but graphviz, in my opinion. The tree list optional t current node t previous node. Actually, we could, yeah. Okay, so we get com. So if our current node is null, it means that it is our first call to the function. So we can just concat graph with a high DPI of 300. The nodes will have no box around them, so plain text. The graph will, and I could also just API bg color equals transparent. Okay, so this is our initial string. So the first okay, so a tree will be sent as a list of only one element here. So we can just call list and we get actually a better result. So if we have, let's see how we, okay, so the nodes are declared as a number with the label text. I think it will be better to create a unique identifier based on the text. Oh, would it? No, an identifier wouldn't work. Or would it? Would it work with as a string? It might. It might work as a string. For example, if we have a node that is called plus back, and we also specify the label equals label back, and we get here some random string to make it useful. One car list gives you just the first item. It's 3 rather than the whole list. Well, the thing is that my list only has 1 root item. I don't have for now a use for lists with 2 root items, so car just gives me directly the element vowel and all of its children. So that I don't see it as an issue for now. Maybe in the future I will need more root elements, but I guess that's an issue for future Pendrek to think about, not an issue that I have myself to think about right now. Also, unique idea. How did I create unique strings? Unique idea, new concat message make fqdn message make fqdn message.elo, and I should add here that's a require message. Hopefully, yeah, okay. So message make fqdn. What does it yield? Drak-pa. Yeah, no, that's not. Unique id.pl. Unique idea. ID new. So yeah, when org ID. Okay. So org ID time to be 36. Org ID time to be 36. What does it yield? Okay, that looks good. That's something that we can use. So right, so fn node from list. So we have the node, and I don't think we need even the concept of generation that I had in my code previously. Can just format %s label equals %s, and that will be and twice %s with a dash, just because. Car t node org 80 time to b36 and car t node. Okay, so if we get here and we calling declare nodes from list, also why do I have two spaces here? The result will be vowel. Yeah, it looks good. Looks good. Let's remove the result verbatim. I missed a bracket. Let's quit bracket. Yes. Okay. Now the question is also proton here, for example. Graphviz. Alright, let's put everything back where it should be. Back. Label equals back. And ABC back. Right. No all whether executes function for that. What happened again? Graphviz. Yeah, okay. There is an error here. Okay, so if we get this, okay, so yeah, I had one issue, and if we open this image, I'm not sure. Yeah, okay, alright, it works. It works. It works, so we don't have any kind of restriction if the name of the node is between quote marks. Oops. Right. So back here we get vowels plus a random string. Okay, so the random string is here to avoid collisions with some other potentially identical nodes. So for example, we have no collision between positive things here and positive things here. So the only downside is that we will get a modified identifier each time, which means that I will have more stuff to keep track of. Well, if I don't modify it, no, I don't think it will be an issue actually. I don't think it will be an issue. All right. Okay, so we got our node declarer for the list. So conlanging declare node from list list. Okay. What does the other function do then? Concat. Okay. Conlanging tree to dot. Okay, so current node list, current node, previous node. I think I can remove current node here to make it a bit easier, and previous node, that is here. And now conlanging tree to graphviz with so let's get back to our car list. Result. Verbatim. Yes. So SLC, nice, so we can modify it a bit. So we get that we get an unordered list. Ordered I and ordered you. Let's disable file check because it's generating more noise than anything that is helpful here. Okay, so if we got an unordered, if we get a list that begins with unordered, actually we could just discard it altogether and we get either one or more elements. So each time we can actually do a car of the list. So tree to graphviz. So concat. Okay, so we get our calling declare node from list. Let label name. And it's concat car list. Okay, pretty good idea for a package. Thank you, Gavin, and hello, welcome to the stream. And org idea time to okay. So this is our label's name. And we should actually, can we just grab that label's name? Label let label car list. Okay, and we replace that by label. We can just make that a one-liner. It's not that hard to read. Label name, and now we replace by concat. The format inside the concat isn't the best idea, but that's what we have. Label equals, alright, person s, label name and label, and calling list, calling tree to graphviz to list. So now we will. So it's not car because we don't want the unordered. We want the CDAR because we don't care about the unordered element here. We want our back and minus back elements. CDAR list, and we will pass also the label name. So we can back reference it from, well, we can reference it from calls down the line. So no, and okay, so I guess that's our first call to the function made. Our second call, what do I do for the, so atom, or whether it's an atom or a list. In our case, we can only have lists when we call CDAR to list. CDAR, which basically means take the CAR of the list and then return its CAR. So we just basically eliminate unordered. Yeah. So we can only get either a list or null. Yeah, we can get a null of t3, so null of t3. Null t3 will return just an empty string, because that means that we went all the way down the tree. Okay, so that's, and in case and otherwise, list p3 and get my parentheses right. And just to see what we get here, 3 and t previous node, just to see. Okay, so let's do again an Emacs list block here. Our variable list, it equals to new vowels. A little program here just to make sure. And we get to write concatenating tree to graphviz and list, and it's not tree, it's oh, I misnamed the function. List to graphviz tree list. Okay. Wrong type argument character P vowel. Huh. Toggle debug on error. Yes. Concat. Oh, right. Concat. Let label. CDL test. So label car to list car. Oh, because, yeah, okay. Of course, that's something I even mentioned, but I forgot about it. Tier list is car of tier list because we have only one element in our list. Yes. Now CDR of vowel. What? Tree to graphviz CDR. Yeah, it's not CDAR, it's perhaps you have to call the function for every nested item. Yeah, I have to call the function for each of them, yeah. Or iterate and concat somehow. Yeah, no, it will be a recursive function that will be called on every single node. That's basically how I picture it. That's how the current conlanging tree to dot function that we got here works. Basically, yeah, it's a recursive function that goes over every single node. So tier list. CADR. Maybe did I get the order wrong here? Was variable T3? Yeah, because T3 doesn't work. It's T list. And conlanging list to graphviz. And a list. Okay. Let's try that again. Yes. Okay. So we get our first node, and we got to see here. Yes. Well, an ordered bug. Oh. Message CADR. Message list. Previous node. Okay, just so I can be sure. List previous node. Okay, so I just cdr'd here. And if I see ADR, I mean, yeah. I mean, it seems like the tree node has multiple children, so the recursive call should happen for each child. Yeah, indeed. So basically, what I will do is that each time I call the function on a node, I will evaluate the function itself on each children of the current node and concatenate the result for each one of them. And if a node is a leaf of the tree, then we will simply try to call the function with a null list, which is why we have this here, and it will return an empty string and it won't call the function anymore. So yeah, that's basically what will happen. Oh yeah, the recursion is the most straightforward thing to set up. It is not. I remember the first time I tried to write something like that. It took me so much time, and I wasn't even really used to use any kind of Lisp, so it was a lot of mental gymnastics for me. And now it's much better, but yeah, when you begin to try and use Lisp or any kind of Lisp dialect, so hard. So if I execute that again. Come on. Unordered, okay, so if I add another scatter, I'm really not. Oh, come on. Yep. Wrong. It's not cover. These functions are not really list vowel. What? Okay, so cutter just goes straight here. List unordered. It's not cutted, it's not CAAR. It's CAADR. List unordered. CAADR. Because if we get so we get list, okay, which is already called. So we get here ball. So a CDR should get us. A CDR should get us this, right? Because here we have T-list, we get here. I'm not sure what is happening. CDR T-list. I will rename it just to be sure that we don't have any previous node. Don't worry about that. Just so that we are sure we don't have any name collision. List CADR list. And if we just CDR list, what do we get? List and ordered. Okay, so CADR. Oh, CDADR. Maybe. I'm just straight stuff, I'll be honest here. Yes! Alright. We got what we need. Right, so here we have a list of elements. So, for example, if I come back and do a do list of element over T-list, and I message LM, I should get plus back and negative back of carve LM. Yes, okay, perfect. So we can use our do list. That is good. Let's see what I did here. If list p, okay, concat, calling tree to dot and car and CDR. So I have no option of having multiple. More than 2 children of a list. Message the length of I'm just curious about that. No. Okay, there we go. length is 2. So we can note that if the length of an element is 2, it has children. If the length of an element is 1, it is a leaf. And if it is a leaf, we can just return. We don't need to even call the function. Let me remove this program. It doesn't. Okay, so do list element, to list element. Okay, so we could do a let and have our and have the result of the call of the current node stored inside a graph string that is initially empty, into which we will add progressively everything that we need. And we can return graph str here, and each time we evaluate something we can just set f or set q or set f. No, set f the concatenation of the current iteration over the previous iteration over TList. So we also get our current label, which is the car of TList, and our label name, which is the concatenation of labels. So we need this to be a let star dash old 88 time to and I guess I could actually label name also name that correctly. So do list set f graph str as the concatenation of or format. I need to use too much concatenation. Format. Alright. Format of label equals this and this. Percent s here. And percent s here. Label name, and here we have the result of our call. Well, we just have declared a new label. We should also declare the connection between the previous label and the current label, and then the rest. So that is the previous node label. Label name. that's actually label name, and that is label. Okay. And the last $s is our call to landing list to graphviz cd adr list to list, sorry, and label name. And of course, we need to prefix all that by graphstr. What is it about list? And use lexical ln. Oh yeah, because yeah, of course. This should be declared here. Right. And use lexical variable and ln for ln. It's actually ln here at that label. I think we should be good like this. Let graphstr, which is an empty string. Now for each element of the current level, we get the level and we concatenate the previous string with our new label here. Okay. Then we link our new label, well, our new element to the previous element. And then for each, and then we call plugin list graphviz on the current node. So we can do the same for its children. I think we are pretty good here. And concat another, yeah, of course. Of course. Let's do this until list graph itself to list. Let message and then LM and positive back, but we don't have negative back. I'm surprised. Let grab pass str do this. Message. List. List. Okay, so list we got back here. Positive back and then negative back. Okay, so and here we get positive back and negative back. Huh. Oh yeah, of course. Let's just ignore the recursive call for now. SLC dot. So we get oh yeah, and we need to put that between quote marks. Okay. Just add some new lines to make it a bit more readable. It's a specific what? Ah yeah. Okay, so make it a bit more readable. Okay, so and apparently I forgot one last element. Okay. So what do we have here? We have a vol back, a link vol with back. Then we create negative back and we link vol with negative back. All right, that sounds nice. So let's remove these messages. And let's instead message list cd_adr element. list. Okay, cd ADR. CADRDR. Because apparently we get a list of elements here. Yep, okay, so and this is not TLS here, this is M. And I think it works. Okay, let's save that as tmp lists.org. Okay. Alright. What the what the pin? Oh, come on! Oh, Emacs left. OBS. Okay. OBS. Do we? No, we don't see. We don't see Emacs anymore. Emacs. Let's bring back Emacs. Okay, Emacs is back. Right. Don't know what happened. Okay. Let's try to compile that. Near line 3. Shape equals plain text. Okay, so we get it here. Calling the EL. Shape equals plain text, and here we have shape plain text. Yep, I can see the issue here. Shape equals plain text, and time for the truth. Boom. Oh yes. Oh yes, that feels good. It works. And we've done that in a bit over an hour. If we count also the time I spent explaining what I want to do and all. So yeah, let's try that with another list. Also, I will remove all the new lines here. So we can get some code that is a bit more compact. Okay, so now name consonants. Yep. The consonants are here. Let's see if we can easily consonants. So we get here a coronal feature and a non-coronal feature, interior feature, non-interior feature, a voice feature, no voice feature, nasal and non-nasal, and now inside quotes. Oh, fuck off. Right, and non-nasal should be this, and non-voice should be this. Okay. So we finish with the interior here. Minus interior positive voice. I say positive, not negative. Negative voice here. And we get this for positive voice, and for negative voice we get this. Right? This is coronal, not coronal or something. So voice again. A negative voice. Positive nasal. Negative nasal. Positive labial. Negative labial. Okay, below is this labial. Okay, on nasal. Continuant. Negative continuant. Get this. Okay, so we are done with the positive voicing. And negative voicing, it's labial or non-labial. So labial and non-labial, and we get this, and we get this. Okay, so I call it consonants with an S. Consonants. And the output file looks great. Let me see the output file here. It's about the same. It's basically the same, yeah? Except that I did change a bit what was written here and there. And I see that I wrote labida somewhere. Yeah, consonants. Labida. Yeah, it seems to work. Labial, non-labial, continued, non-continued. Okay, that's great. I'm really happy with it. Now there's just one thing that I would like to try, which is to add some zero weight. So just ifn clanging declare no list for list name t label and it's basically format $s label equals $s name and t label. Okay, so format. How is it? What? Oh yeah. I'm stupid. Right. So we can replace this with clanging declare for list. Okay. And let's change this to this. Okay. And the clanging declare for list label name label. Okay. So now it shouldn't change a whole lot. The output, yep, doesn't change a whole lot. If I add a weight of 0, does it help to get a more balanced tree? You can see that it added weight equals 0 to basically everywhere. Nah, didn't change a thing. Okay, so I will revert the last change. All right. And I think we are pretty good. I am a bit surprised that it doesn't have some nice macro to format strings. Format looks like something from C. Yeah, I agree. Like something like more similar to Python, like something like you could write, for example, f your string and then I don't know, special syntax to write your org ID list, something like that, and then the rest of your string and something like that. That could be nice to have. I agree. Format, yeah, format I think is very heavily influenced by C. That could be a nice extension to add to Emacs though. Maybe something to think about. Oh yeah, I agree that format is. By the way, I could here use concat, but nah. I will keep format. I'm not sure. But yeah, the format issue is yeah, that's exactly what I was thinking about. Latency seems huge. Yeah, I put in YouTube the latency, normal latency, not low or very low latency, because yeah, I was worried about my internet connection. I had no idea how it would hold in. Hang on. Oh. It seems like my Linux decided to crash. I cannot, or maybe dump. I can only work from inside Emacs right now. I cannot go from window to window. Can I click? No, I can't even click. I can't even click on OBS right now, so I guess I will have to end the stream in style when I will have to end it. Right, so let's just add these auto loads over here. Not here. Yeah. Well, yeah, it seems that the current code is a bit simpler, well, simpler I don't know, but it required less cond possibilities here. So let graphstr do list, again a let, I can remove the message here, set f graphstr format. Yeah, the format. I'm not really happy with the format itself, but yeah, I just said a better macro or something would be much nicer to have. All right. Well, let's commit that. Let's commit that. Also, I think, yeah, it's not the correct remote that I have here. Hang on. If I do repos calling is show info banner. No, it's not correct here. Which one did I? From Git, Emacs, issue info banner. Git at GitHub. Directly issue info banner. Remote. Configure labs. Git at labs@pendrect.com. Okay. So configure origin. Git at labs.pendrect.com. pendrect.el.git. Hopefully that will work. Okay, so add function for creating graphviz images from org mode lists. From org lists, and add with a double D. Okay. And can I push? Pushing. Yep. pushed. Great. So that's a great success, I guess. And I will soon modify in my files the way that I create my images. It will be much more maintainable than what I have right now. As a reminder, or calling, okay. As a reminder, these are the lists that I have right now, and currently in my other files I need to declare this. I don't know what about you, but I think that this will be a bit nicer to use, like a bit more, I don't even, you know, like it's just, yeah, it's just nicer to see, and it's even easier to modify here and there, and it's, oh, right, and yeah, it's even easier to just fold it where needed. So yeah, I'm pretty happy with the result. So yeah, we managed to write it in about 1 hour, and so yeah, that's so thank you everyone for watching this stream. I hope you enjoyed it. The modifications were just pushed to so it's calling the EL to my repo on where I didn't, yeah, org is really great in terms that you can access org structures from the code. Yeah. So yeah, it's as I said at the beginning of the stream, I had no idea that you could use lists in org mode as a source, as the source data from other code blocks that you had in Emacs Lisp, or even it's most probably even available in other languages such as Python. But yeah, I must thank Ashras from the System Crafters Discord, because they are the one who showed with a code snippet that it was possible, and I had no idea that it was possible. I always did that only with tables and with other code blocks, and yeah, I've had to transfer some of my work from org to Jupyter notebooks. That's something I definitively missed. Yeah, I can understand. I can understand Jupyter. Maybe you could use an org to Jupyter notebook exporters if you need Jupyter notebooks to work with other people. Maybe that's a possibility. I don't know. But yeah, definitively a big thanks to everyone from the System Crafters Discord, because all the new information that goes through this Discord basically every day is just, I just love seeing all of that, and everyone just speaking about Emacs Lisp, and even other topics that I'm not particularly interested in. Like when I see people speaking about gigs, I'm not a gigs user, but it's still nice to see how it works with on other people's machines. So yeah, shout out to everyone from there. And thank you for following this live stream. I don't know when I will do another one, but I hope I will see you soon, and I wish you a good one. And as I said, my window manager crashed, so I cannot end the stream normally, so I will end the stream by shutting down my machine. Have a good one, and well, for me it's evening, so good evening everyone, and good day if it is the day, good night if it is the night. And I will maybe see you